Hello. In this video, I wanted to show an example of running a trace of an algorithm. So, in this particular example, I'm going to use the number, I don't know, let's do 31. We're going to trace this. So, in this case, n would be 31, which then means q would also be 31. And that was like a 9. Q is 31. And we would start off with I being equal to 0. So now when we go into a while loop down here, we will have r sub I. So this will be r sub 0. This will be equal to this number 31 divided by 2. And we want the remainder of that. So 31 divided by 2. Remainder of that will be 1. The quotient itself is whatever that, how many times that goes in evenly, which will be 15. And then I iterates. This now goes up to 1. So now r sub 1 will be equal to now whatever 15 divided by 2 is. The remainder of that would be 1 again. Q would then be 7. I iterates another time. We have r sub 2 now being, divide that by 2, remainder 1. Q then would be equal to 3. I iterates another time. R sub 3 now is also going to be 1. We will then go to, and let me just space this off. Okay. We then get a Q then of 1 when we divide that by 2. So then I iterates again, now to 4. When we divide 1 by 2, we get a remainder. So r sub 4. That is going to be equal to 1. And q then would be 0. And since we got 0 here, we don't want q to be 0. So this ends the while loop, and that would be our trace of this particular algorithm using an n of 31. We could then rewrite the number instead of binary based upon all those remainders. For the number 31, if we wanted to write that very quickly in binary, that is 1, 1, 1, 1, 1. So this will be, let's see, 2 to the 0, 2 to the first, 2 squared, cubed, and fourth. So this will be 16 plus 8 plus 4 plus 2 plus 1. This makes 24, 28, 31. So that's an example of how to write that instead of binary while tracing this particular algorithm. Thank you.